Good evening and good morning to all of our participants, and thank you for joining us today for this discussion focused on industrial decarbonization opportunities in the US and China. I'm Jen Perrin with the California-China Climate Institute, and will be serving as the moderator for today's discussion. We're so pleased that you all could join us, and we're looking forward to the conversation today. So before we begin, I'd like to offer just a few quick housekeeping remarks. We are simultaneously translating this event. So at the base of your screen, you'll see a globe icon, and you can select the language that you would like to listen in, either English or Mandarin Chinese. In addition, throughout the course of today's discussion, if you would like to ask a question of any of our panelists, you are welcome to enter that in the Q&A function at the base of the screen. The chat function is disabled, but the Q&A function should be working for the audience. So feel free to enter your questions there at any time throughout our discussion, and we'll engage in the interactive portion of our discussion toward the end. And finally, we are recording this event. It will later be available on the California-China Climate Institute's website and YouTube channels. So let's go ahead and get started. So today's program is one of a broader series that we've been working on here at the California-China Climate Institute, really focusing in on opportunities for the US and for China to take accelerated climate action within this current decade, within the 2020s. Based on the sectoral topics that were agreed in the Glasgow Declaration at COP26. And so in relation to that, we've launched an 11-paper series. Perhaps my colleague can put the link in the chat, that really focuses in on a variety of different sectoral opportunities for the US and China. So to help foster this accelerated climate action, we convened a wide suite of issue experts focused on the different thematic and sectoral focal areas, from the power sector to buildings, to methane, to deforestation and low carbon transportation, other topics as well. To really identify both progress to date and challenges and opportunities for the US and China to move forward within this current decade. So today we're going to focus in on one of those sector areas, industrial decarbonization, and a related report that focuses in on the industrial decarbonization opportunities for the US and China. We have a variety of issue experts here with us today to further explore this option, and then we'll engage in kind of an interactive discussion. So to begin, I'm very pleased to introduce our first presenter, who is Julia Thane, who is a senior principal at the Rocky Mountain Institute, and is going to focus on some opportunities here in the United States. Julia leads a new global program at the Rocky Mountain Institute, working with cities to reduce transportation emissions and investing in equitable mobility options, as well as building affordable and accessible new housing. So her team uses data-informed research to help cities target key policies for impact, develop and implement transformational projects, and build stakeholder support. So over to you, Julia, for your remarks.
Fantastic. Well, Jennifer, thank you so much for having me here today. And thanks to my fellow panelists. I'm very excited about this discussion. So Jennifer and audience, just to take a step back before taking a step forward, as Jennifer mentioned, my name is Julia Thane. I'm a senior principal now with our Climate Aligned Industries program at Rocky Mountain Institute. At Rocky Mountain Institute, focus on our work on clean industrial hubs. So just to take a step back, Rocky Mountain Institute is a 40-year-old sustainability nonprofit that has focused on accelerating the clean energy transition for all. We partner with another organization called the Mission Possible Partnership, which is a coalition of 400+ organizations that span public and private sectors, policymakers, supply, demand, community engagement, and finance, who are all committed to industrial decarbonization. And what I want to talk to you about today is how we're thinking about doing this in the US and how the Inflation Reduction Act has changed that. So you all know, and the reason you're here is because of the size of the problem. Globally, industrial activity is 30% of current global greenhouse gas emissions. It's the same in the US. And if we are going to manage to reach our 2030 targets and maintain alignment with 1.5 degrees, sometimes you have to dig into the hard to abate sectors. So the way in which we're thinking about doing this with Rocky Mountain Institute and with the Mission Possible partnership is by actually digging in to each of the hard to abate sectors, so all 7 of them, and thinking about how investments need to shift in order to reduce emissions. One of the first things that we did as a team with RMI and Mission Possible partnership was establish what we call sector transition strategies. So we looked at aviation, at shipping, at trucking, steel, chemicals, aluminum, and cement and concrete, and started to figure out what do we have today on the ground in terms of industrial facilities, in terms of vessels, in terms of aircrafts, in terms of vehicles, and what do we need by 2030? And what we realize is probably something that you all know, which is we don't have nearly enough of everything we need in order to reach the size of the problem. So for example, in aviation, we have just 70 SAF or sustainable aviation fuels plants globally operational or in the pipeline, and then about 300 plants that we need to get to. So what do we do about that? What do we do about the size of the problem? That's where we think these regional clusters will come in. So industrial decarbonization, our hypothesis is that it's going to have to happen in what we call these clean industrial hubs. With Mission Possible partnership, we looked globally and actually mapped out where we thought the potential supply hubs might be of hydrogen, of low carbon fuels, of renewable electricities, where the potential demand hubs might be for those 7 hard to abate sectors, and then where both supply and demand lived together. So places like Los Angeles and Houston. And the idea here is that with clean industrial hubs or with these regional clusters, really the supply of the energy needs to be matched with the demand for the energy. Both need to be supported by an underlying foundation of policy, of finance, of community engagement. And that with a combination of these things and the sort of interstitial links between the various projects, that's how you'll really get this sort of industrial decarbonization to scale. So the work that I'm leading at RMI actually is through the Bezos Earth Fund. And what it allows us to do is to catalyze industrial decarbonization in 2 geographies, so in Houston and in Los Angeles. And what we're doing there is first mapping out where the industrial facilities and emissions are in the Gulf Coast and also in California, and also what types of emissions we should be going after. So we're finding, even within the US, just the size of the problem is so much different. In the Gulf Coast, for example, you have roughly, 2/3 as many, or 2/3 more, industrial facilities than you do in California, emitting about twice as much of the emissions. In California, the emissions are coming much more from aviation, shipping, and trucking, for example. I could talk a little bit about it later in terms of the types of work we're doing. But in what we're finding as we work on the ground in California, in Texas, in order to support what we call these first mover projects, so investments that are $100 million or more in industrial decarbonization, is that many of these are considered almost too risky for investors to invest in, that they are still looking at the economics of hydrogen production and the different colors of hydrogen production and trying to figure out how much of their portfolio they're really interested in investing in that. Same thing is true with low carbon fuels, although maybe the risk tolerance is a little bit different. Midstream infrastructure is something that has yet to be planned for, especially as we think about transitioning to different types of fuels, whether it's drop-in low carbon fuels or whether it's clean hydrogen that might require retrofitting of pipelines or different mechanisms of delivery via truck or train. And certainly then when it comes to pulling together the users and off-takers of the different types of fuels, these are markets that have yet to be made. And so there's quite a bit of work to be done in terms of bringing these market actors together. But what I'll say is, just to conclude some of the remarks around what's happening in the US, certainly the Inflation Reduction Act has almost completely changed the calculus of how we're thinking about industrial decarbonization. And it's not really hyperbole to say that it has just probably moved us 10 years into the future in terms of what we're going to be able to do in the country and with regards to both supply and demand. This slide just shows how the funding is starting to shake out across the Department of Energy, the U.S. Environmental Protection Agency, and the Department of the Treasury, with the Department of Energy having roughly $316 billion worth of financing and grants that it is dispersing over the next few years, with the U.S. EPA around $32 billion, and then the sort of big treasure chest of the Inflation Reduction Act is actually all the tax credits that the Department of Treasury is starting to put out guidance for. And some of our work is really working with companies to figure out how what we call the 45s, so all of these different tax credits from the Treasury, are really going to change, again, the economics of whether hydrogen makes sense, for example, or SAF makes sense, for example, to transition to and transition to faster. And so I think in addition to the Inflation Reduction Act, just the fact that we've had the Infrastructure Investment and Jobs Act providing billions of dollars for the purchase, upgrade, and installation of low carbon technology. And these are just a few of the programs that are related to industrial decarbonization, has made, again, the US be able to fast forward its progress in terms of industrial decarbonization. So very much looking forward to this conversation. I think, again, in the US, it's like basically right now, industrial decarbonization is so much about how the Inflation Reduction Act and the Infrastructure Investment and Jobs Act are going to change the economics of facility upgrades or of energy production. And certainly what our main hypothesis is that we're not, going to see this sort of like scattershot across the country, but more so focused in these regional clusters that are going to be able to pull together supply, demand with the underlying policy and finance and community engagement. So I'll go ahead and stop there and turn it back over to you, Jennifer.
Thanks so much, Julia, for those remarks. I really appreciate some of those practical perspectives and examples that you offered about how new federal legislation is playing out here domestically in the US. And so now we're going to turn a bit to the Chinese context. So we have some additional colleagues here who can help us better understand that. So first, I'm going to turn to Hongyu Liu, who is an energy and environment technology researcher at Lawrence Berkeley National Laboratory, where she focuses on the decarbonization of energy-intensive industries such as cement and iron and steel and the petrochemical sector. So over to you, Hongyu, to share some of your recent work, including on this recent report that we'll put a link in the chat.
Thank you, Jen. Thank you for the warm introduction. Hello, everyone. My name is Hongyu from the Berkeley Lab. I'm really glad to have to join today's webinar with so many experts on the panel and in the participants. I see so many familiar names, so thank you for joining, and glad to talk about the opportunities for enhanced near-term US-China climate action and focusing on industrial decarbonization. As Julia mentioned, the industry sector is really important for both China and United States. As you know, the industry accounted for about 60% of China's total greenhouse gas emissions, and about 30% of that for the US emissions. And if we take one step closer and look into the China side, we see that the 5 heavy industries accounted for 87% of total manufacturing energy use in China in 2020. And these are the familiar sectors that we all know about: the steel, the cement, the chemicals. And I'd also like to point out that the light industries are responsible for about 13%. The rest of that goes to the light industries, about 13%. And another interesting thing to know, and I think we are aware of that as well, that China's industrial sector's energy supply is heavily dependent on fossil fuels. As you can see here, actually 70% of the industrial energy use comes from fossil fuels. And actually 50% of that, of the total industrial final energy use, come from coal and coal-related products like coke. So it's a very energy and carbon intensive sector. And given there are so many different industrial sectors and are so different from each other, and they are so heavily dominated by use of fossil fuels, and we have to look at a variety of different technologies and measures. And today I would like to highlight on two sets of strategies. And one is on the energy supply side and focusing on electrification. And another one is on the material demand side and focusing on material efficiency. Let's look at electrification, and we'll start here. We see that there's several interesting things going on. While the light industries, as mentioned earlier, only accounted for 13% of the total industrial energy use in China, it's a relatively small share. But given the size of China's industrial sector, even a small percentage is a lot, and reducing fossil fuel consumption in the light industries represents a significant opportunity. And if we look into the light industries, we see there's three things that are interesting. One is showing on the left that you see that several the electricity already play a quite dominant role in several of the light industries. For example, in 2018, you see that the electricity already accounted for almost 80% of the final energy use in electronics sector and about 64% in machinery manufacturing. But there's some other sectors like textiles and food and beverage processing and tobacco industries have a relatively small share of electricity use. So that's number one. Number two, we see that the light industries have a relatively low temperature process heat requirement. And showing here on your right that you see that textiles, medicine production, and manufacturing of metal products, almost all of their thermal energy demand has a temperature need that's below 150 degrees Celsius. And for other industries such as food and beverage and tobacco, about 80% of their thermal energy demand is at 150 degrees Celsius or below. So this really represents an opportunity for something that we can do right now. And the third interesting thing for the light industries is that these industries' energy demand is not as complex, not as heavily integrated as, say, comparing to a petrochemical facility, a petroleum refining facility. So they are much more straightforward, less complicated, and easier to implement electrification technologies. And if we look at the list of commercialized and emerging electro technologies on the market or in the labs, we see there's several like electric boilers, hybrid boilers, industrial heat pumps listing on the top of the table. They're already commercialized and we can procure them, we can buy them, we can implement them in the facilities today, right? We're talking about near term things we can do right now. That's why we think the lighting industries may be an interesting target for us to look into that. And as you know, switching from on-site fossil fuel heat production to electrification technologies, such as switching to coal-fired boiler, switching from coal-fired boilers to industrial heat pumps, can also bring us other benefits, such as improved energy efficiency, reduced cost in terms of maintenance and insurance, improved productivity, reduced air pollution. So there's some other benefits to consider as well. But as you expected, and a big caveat that we need to have is that pursuing this route of decarbonization in industry using electrification technologies need to be supported by, need to be pursued together with a fastly decarbonizing power sector. We need to have both going at the same time. Here I put on some other technologies, renewable heat technologies that's providing heat not using electricity, but using solar, geothermal, and biomass. And you can see that the temperature range they can supply to is about 200 up to 200 degrees Celsius right now. That's why we think it's an interesting thing for us to look into the light industry. If I may, I'd like to turn your attention to the second set of strategy I mentioned earlier on material efficiency and use cement and concrete as an example. Traditionally, a lot of attention has been focusing on how do we reduce carbon dioxide emissions from clinker production, and how do we use amount of clinker that's needed to make cement. And both areas are super important, and we have made great progress in both areas. And I think both areas will continue to play a significant role moving forward as well. But thinking one step back and thinking, why do we need to make cement and concrete? And how are we using cement? And we actually open up more options. We can use more different strategies if we look at from the value chain perspective, thinking about what are the measures we could really reduce cement in concrete? What are the measures that we could reduce the use of concrete in buildings and construction projects? And can we make more efficient use or reuse of buildings and build construction materials? And this really opened up more strategies and measures and technologies. You see some of them are mentioned here, and some of them, for example, improved building design, use precast components, extending building lifetime. Some of them are commercialized. We know how to do it. Other countries are doing it, but for a number of barriers, market barriers, institutional barriers, we don't see that completely adopted in China. And we see that's an opportunity that we can do something about right now. In fact, at Berkeley Lab, my colleagues and I, we've done a study and look into exactly this question of seeing how can we reduce embodied emissions of building materials in China, and what are the pathways. And we see that it's possible to achieve near zero emissions by 2060 in China's building material sector. And we see that material efficiency strategies, as we discussed earlier, play one of the most important roles, especially in the near term. Actually, in our estimate, counts about 50% of the total CO2 emission reduction by 2030 has that potential to do that. And this roadmap includes not only cement, but also steel, aluminum, and glass. And we looked into each one of them and applied different but similar material efficiency strategies. Lastly, I would end here. In our report that we wrote together, we recommend several things that China and US can collaborate on, including these critical areas, such as industrial heat, electrification, and low carbon building materials. And given the time today, we won't go into the detail of each of these recommendations, but I encourage you to take a look at our report. And if you are interested to find out more information about these technologies, about these policy recommendations, and it's also translated into Chinese. Thank you for the opportunity. I look forward to the discussion.
Thank you so much, Hongyu. Great, and thank you for teeing up some of those opportunities for collaboration. We'll get into some more of those, I imagine, in the interactive portion of our discussion, so look forward to looping back on those topics. In the meantime, I'll just remind our audience that if you do have any questions at any point for any of our panelists, feel free to start entering those in the Q&A function at the base of your screen. We'll get to that a little bit later in our program today. But first, I'm going to introduce Professor Zhang, who is a professor in the Department of Thermal Engineering at Northeastern University of China. He is the Vice President of the Low Carbon Steel Frontier Technology Research Institute at the university and a visiting scholar at Lawrence Berkeley National Lab as well. He has contributed to an expert group focused on low carbon iron and steel and has carried out very significant research focused on industrial systems and carbon peaking pathways, and is very extensively published in academic literature. So over to you, Professor Zhang, for your remarks.
Thank you very much. Ladies and gentlemen, good afternoon and good morning. I'm Qi Zhang and come from Northeastern University. It's my honor to attend the opportunity for a near-term U.S. industrial decarbonization. Thank you for your invitation. In order to give expression to my remarks, I will make my presentation in Chinese. Thank you very much. 非常抱歉啊，因为这个我最近一直在出差，所以没有抱歉。那么下面呢，我这个从4个方面吧，这个介绍一下这个。我的能源材料等消耗量巨大，大家也很清楚。那么据最新的数据显示啊，就是能源生产和工业生产过程中的碳排放量，约占中国的总的碳排放量的比例大概是85%啊。那么工业碳排放呢是其中的重中之重。那么工业领域呢，最主要的就是钢铁、有色、化工和建材工业，这是在中国的一个情况。那么这几个行业呢，贡献了40%左右的碳排放，这是在全国总量的比例啊，这不是工业部门的。那么当前呢，中国正处于快速的发展阶段啊，未来对工业原料和这个工业产品的需求仍将保持增长态势。那么在碳达峰、碳中和目标下呢，中国工业的领域的节能降碳这个工作呢，面临着多重的压力。那么根据这工业系统的特点呢，我们从供给侧、需求侧、技术侧和这个经济侧等多方面的共同发力，加快工业的碳中和目标的实现。也就是这个那实际上我们在这个报告里也提到这些问题。那么第二个想给大家介绍一下，就是关于针对二氧化碳排放、碳中和目标啊，这个中国这个从上层国家层面出台了哪些相关政策和措施啊？我简单的总结一下。那么从2020年这个9月22日，这个中国提出将提高国家自主贡献力度，采取更加有力的政策和措施。那么二氧化碳排放力争于2030年前实现碳达峰，2060年前实现碳中和目标以来。中国从政府部门，那么相继出台了这个一系列的这个政策文件，比如说中共中央、国务院关于完整、准确、全面贯彻新发展理念，做好碳达峰、碳中和目标的意见，以及2030年前碳达峰行动方案相继发布。那其他这个各大部委呢，也相应的出台了相关的政策。那么这些政策呢，是为实现双碳目标做出顶层设计，明确了碳达峰、碳中和工作的时间表、路线图和施工图。那么此后呢，在工业领域，尤其是能源、工业领域，包括交通领域等重点领域实施方案，煤炭、石油、钢铁、有色、金属、化工、建材等重点行业的实施方案，科技支撑、财政支撑等等，都已进行了一个相应的这个支撑的方案的出台，也就是说，这个支撑这个中国的工业领域的碳达峰、碳中和的目标啊。那么总体来看呢，就是从国家层面已经形成了这个相应的1+N 的政策体系，形成各方面共同推进的良好格局，为实现这个这个工业领域的脱碳呢，提供了一个非常大力的支持。 当然说实现双碳目标呢，还需要很多努力。那么绿色低碳经济政策呢，也在逐步完善，双碳工作的激励约束机制呢，也在不断健全。那这些都为实现工业领域的碳中和呢，提供了重要的保障。这个是从政策方面。下面呢，我简单的第3个方面是想以钢铁为例的，简单给大家介绍一下我们近期做的一些工作。那么针对中国钢铁行业，我们碳中和的路径和降碳的潜力啊，大家都知道，中国钢铁工业呢是以高炉转炉生产流程为主，我们这个比例呢占到90%以上。另外一个就是以高碳能源为主，这样的能源结构，那么造成了钢铁行业的这个能源消耗高、碳排放量比较高这样的一个现状。那么这个围绕这个中国钢铁行业的这个脱碳。下7个方面啊，这个进行，一个是需求减量，比如说这个我们生产高性能的这个，刚才也有专家介绍，我们生产高性能的绿色产品，然后提升这个产品的使用寿命的，那达到这个需求减量，从而把这个钢产量降下来，这第一个。第二就是采用的先进的节能减排技术呢，实现能效提升啊，就是 energy efficiency improvement， 就是能效提升啊。第3个就是结构调整啊，我刚才介绍了，这个目前的中国的钢铁行业是以高炉转炉流程为主，那么像美国啊，那主要是以电炉流程为主，所以这个在这个转变过程当中的结构的调整非常重要的措施啊。那么第4个就是技术突破啊，刚才洪岳也介绍了一些这个技术相关的内容。那实际上我们在这里边主要就提到这个氢冶金啊。负氢循环啊，这样的一些这个技术的突破，来实现这个节能降碳啊。另外就是能源替代，就是用可再生能源，然后实现能源替代。还有就是产业协同和末端治理啊，这7个方面，然后来实现中国钢铁工业的深度脱碳。对其他行业，比如说水泥行业啊、有色啊等等其他行业。那么基于这个7个方面呢，我们构建了这个动态物质流分析模型和情景分析模型，然后呢给出的一个中国钢铁行业的零碳之路的4个阶段啊。那么第一个就是粗钢产量波动下行的控碳阶段，就是2020到2030年，主要是控碳阶段。那么2030到2040年就是粗钢产量继续下降减碳阶段啊。那么第3个阶段就是粗钢产量处于低质平台期，我们叫低碳阶段啊，在2040到50年。那么到2050到60年的时候，粗钢产量稳定于低质，实现碳中和的这个阶段啊。所以设置4个阶段。那么在不同阶段呢，有不同的这个措施啊。与世界关系呢，我就不再展开这个具体哪些措施。但总体上来看，就是主要通过这个技术突破、结构调整、工艺优化，然后能效提升等等手段，然后在不同的阶段，然后实现不同的目标。那么第4个方面呢，我想介绍一下未来的中国工业脱碳的走向。那这个总体的一个对工业领域的一个深度脱碳走向，也是今天的主题啊，就是这个。主要的这个方面，那么我们认为呢，主要未来可以通过以下4种方式，可以加快工业脱碳的进程。第一就是发展循环经济，提高材料效率。那么刚才这个洪岳也讲到，就是提高这个材料的效率，比如说钢铁、铝包括铜、水泥等这不可缺少的这个材料。那么增长比较大，那么使用这个轻型化的材料，或者是对环境影响较小的材料替代呢，实现材料的再利用、再制造，那么提高材料的效率，实现这样的一个主要的这个目标。那第二就是工业用热的电气化，实际上是用电气化设备取代化石能源燃烧，是未来一个重要的一个措施啊。那么随着电网的这个中国的这个可再生能源的大幅的提升啊，我们的能源结构由原来的以煤为主，到以这个清洁能源为主这样的能源结构这个发展，那么电气化设备它的使用和降碳的潜力逐步的挖掘，所以未来就是要充分这个利用电力，实 实现更大的效率增益。然后电气化呢，大幅的应用之后，除了降碳，还有这个可以减少化石能源、降低成本等等，那么带来这个社会经济和环境效益。那么第二就是工业用热的电气化，这个主要的措施。第三个呢，就是以氢为主要的来源的氢作为化工原料，或者是这个重要的工业用的这个能源和氢冶金。那实际上在多个报告当中都提到包括我们RMI 或者是这个 EF 这样的机构都开展了相关的研究，就是说这个氢肯定是未来是要将实现这个工业深度脱碳中发挥重要作用我们现在也在开展这方面研究，就是说氢到底能够实现什么样的这个脱碳的效果？那在中国的工业这个领域当中有多大的需求？如何去实现这个突破？那么通过这个大家都知道，现在的我们的中国的宝武钢铁包括晋南钢铁、河北钢铁集团都在开展了这个在这个氢的这个氢基的这个氢冶金相关的这种中式的这个生产线的这个商业化运行吧。那么目前来看呢，其效果非常好。那么这些都将为未来的这个氢冶金、氢的那个大幅利用，在工业这个脱碳过程当中发挥重要的作用。第四个就是 CCUS 技术的推广应用就是这个在水泥或者是钢铁行业包括电力行业，那么未来的这个从目前来看，未来的这个尤其是到碳中和时段呢，那脱碳的难度越来越大。那就需要通过这个外界的这种力量，比如 CCUS 或者是森林碳汇的方式，然后来实现这个深度的脱碳。这些呢就将减少这个二氧化碳排放那么实现工业领域的深度脱碳。那么在未来的工业脱碳之路上，我们需要更加积极的行动，包括加强国际合作包括像今天这样的交流，那么共同应对气候变化的挑战我们也将加快这个技术创新和转型的升级。推动绿色的低碳发展，实现经济发展和环境保护的双赢，共同建设一个更加美好的未来。再次感谢今天这个邀请同时也感谢这个几位作者，我们这个在完成这个报告当中对我的大力支持感谢，谢谢大家。
Thank you so much for those remarks and highlighting a wide range of potential approaches, on the production side, the demand side, also technological approaches, and including nature-based sinks as well. So thank you so much for those remarks. I'm now going to turn to Jackie Wong from the Natural Resources Defense Council to offer some insights and perspectives as well in reaction to kind of what she's heard from her colleagues and her own issue expertise on this topic area. So Jackie leads NRDC's Industry, Hydrogen and Innovation Group, which does focus in on the decarbonization of the industrial sector, and also includes deployment of green hydrogen in targeted applications and the development and deployment of emerging technologies. So Jackie, please share your reflections and thoughts.
Thank you so much, Jen. Good evening and good morning. And first of all, I'd like to thank the California China Climate Institute for hosting this webinar and to express gratitude to the 4 authors of this report, including Hongyu Liu and Professor Zhang. I thought that the report provided a really informative snapshot of the sources of industrial emissions in both China and the US. And I really liked that it concisely covered decarbonization opportunities throughout the value chain of these industrial materials, all the way from material design through reuse and recycling. In particular, many of the strategies, measures, and technologies that Hongyu mentioned at different points throughout the value chain, such as material efficiency, often don't get enough attention in discussions about industrial decarbonization. Given time constraints, I'd like to focus my commentary on 4 main points. The first point is a point of emphasis. I particularly liked the suggestion in the report that China and the US could cooperate on developing and harmonizing greenhouse gas emissions accounting standards on industrial products. As the report notes, accurate emissions accounting and disclosure is a necessary enabler of other policies, whether it be green procurement programs, carbon pricing programs, or greenhouse gas emission standards. However, the emissions accounting raises many methodological questions, such as where to define the boundaries for a life cycle analysis of an industrial product. Harmonization of accounting standards across geographies, including China and the US, will be important to ensure apples-to-apples comparisons, which will become increasingly important as carbon border adjustments are put in place around the world. The second point is a friendly amendment. The report included a great set of policy recommendations with a particular focus on technologies and policies that are already available or that can be deployed and scaled up within the next 10 years. And we need to take advantage of these opportunities. But I'd also like to echo some of what Julia and Professor Zhang raised, and specifically the importance of taking action now to bring to market highly innovative, transformative technologies that will be necessary to deeply decarbonize industry. In addition, these can't be one-off policy interventions, but rather there must be a targeted and comprehensive suite of policies to ensure that once we get first-of-a-kind demonstration projects off the ground, they are then quickly followed by second, third, and fourth-of-a-kind projects, and so on. The third point is a note of caution. As we all know, the industrial sector does not exist in a vacuum, and it will be important for us to consider and plan for how various decarbonization levers impact other parts of our energy system and economies. For example, the electrification of industrial heat processes will add significant demands on the electric grid. So we need to be thoughtful about how the grid will need to evolve in order to deliver economically competitive and reliable electricity. In addition, as Professor Zhang said, hydrogen can play an important role in decarbonizing the industrial sector. However, we need to ensure that the use of zero carbon hydrogen is truly zero carbon. In what is a very active issue in the US right now due to the hydrogen tax credits in the Inflation Reduction Act, there is a risk that if there are not strong guardrails in place, energy-intensive electrolyzers could actually increase emissions by resulting in more fossil fuel generation coming online, even if the resulting hydrogen is ostensibly clean. And my final point is an expression of curiosity. Something that I would like to explore and better understand going forward is the emissions reduction potential of the various decarbonization levers that were suggested in the report. For example, I've seen the World Steel Association mention that it's estimated that we currently recycle more than 85% of all steel products that reach the end of their life. I'd be keen to understand if that's true, and if so, how difficult and expensive would it be to get the remaining 15%? That's just one example, of course. To achieve our climate goals, we're going to need to push on all of the decarbonization levers mentioned in the report and today from the other presenters, but having a more granular sense of the size of the prize relative to the difficulty of getting it would help to inform how and where we collectively focus our efforts. Thank you very much, and I look forward to the discussion.
Thanks so much, Jackie, for offering those additional perspectives and raising some questions. I think that we can pose those back to some of the report authors that we have here today and start a conversation around it. But first, to remind our audience, if you do have questions, feel free to add them in the Q&A. We're going to be turning to our interactive portion of the discussion. So I welcome all of the panelists to come on screen now and join us for the Q&A, and I'm curious if Hongyu or Professor Zhang, if either of you want to provide a direct response to any of the questions that Jackie just raised, or any reflections that it brought up for either of you.
Thank you, Jackie. That's a great question, and I often wonder about that too, but I know the aluminum and steel that have a fairly high recycling rates in the US, for example, but I'm not so sure about the rate at that high for China. I don't have that number on top of my head. Maybe Professor Zhang, sorry to pitch that to you, but I don't have that for China, so I cannot say that. But I know in US and in other European countries they're relatively high. But to answer your question, I would worry about some of the material contamination in terms of getting the steel out of the recycled products. I would worry about the materials quality of it to produce high strength steel. Maybe it's okay for low strength, lower value added products, but how can we produce very high strength steel using recycled materials? That's also my own curiosity that I need to figure out. But sorry, Jackie, I ran around and didn't really answer the question. I would just say it will not be so easy. that's my my assumption.
OK， 那回我接着回答一下啊。
好。
OK。我还是用这个中文啊，因为有些怕表达不清楚啊。这个刚才这个Jackie 的问题啊，我再补充一下，就是钢铁的回收率也很高啊，但是这个钢铁的回收期比较长啊。这一次在中国这样的情况，就是我们的钢铁呢大概分3个部分啊，一个是我们的这个制造废钢，就是这个。在钢铁生产过程当中，有些这个不合格的产品，我们在厂内就自动回收了。这部分回收呢，大概占到100%啊，但是这个量很少啊。我们总体上占这个3%到5%啊。另外就是这个在这个，sorry， 另外一部分就是，但是最主要的就是这个折旧废钢，就是比如说这钢铁在这个建造的这个楼房啊，这个家电呀。或者是这个汽车啊等等这样的一个用途是占比是最大的，但这部分回收呢，因为它的时间了长度比较大，但是它的回收呢也在60%以上啊，国内的情况。另外就您刚才讲到就是这个我们现在啊这个原来的这个钢铁的回收啊，确实像您说的，比如说汽车啊这个报废之后它压成一块然后就整体来回收，但这里边呢也涉及到这个。其他的材料，就有油漆啊，或者其他污染物啊，那么对这个，sorry， 再利用啊，确实效果不好。那么现在这个国内，尤其是这2年在做这个分类的回收，就是钢铁啊，比如说这个他把这个汽车也是在分类的分解，然后再回收，就是说优质的钢铁。还用最优质的这个冶炼啊，那么差一点的呢要经过处理之后，然后再回收，那这个效率就提高很多，这是一个。另外一个就是现在这个我们正在那么工程院做的一个项目，就是对这个钢铁从这个生产的要贴上标签，用数字化的标签，要跟踪这个产品。到这个用户，就是这个终端用户啊，等它这个报废之后，因为这个数字标签一直在跟踪这个产品，所以它就再回到这个优质的，再回到这个优质的这个冶炼过程当中，然后其他的再进行处理，这个效率就会这个提高很多。这个当然是我们现在正在这个国家也正在推的这个措施，对未来的这种钢铁啊、铝啊这个。整个这个有效的循环利用会提高很多。OK， 我就说了。
Thank you very much. That was very interesting.
Thank you.
Okay, excellent. I'm curious, for any of our panelists. So Hongyu, you in particular highlighted, the need to rapidly decarbonize across multiple sectors, and that the work in the industrial sector isn't kind of in a vacuum and needs to be in tandem with the power and other sectors as well. And I know in the report you highlighted some kind of more cross-cutting strategies, particularly efficiency gains, but I'm curious if there's any particular strategies you'd like to highlight as having a broad application across a wide range of topic areas, if there are things that have broader application. I'm curious if you want to expand on that element of the report.
Yeah, that's a really good question, Jan. I think several of the concepts, first of all, of several of the strategies, as mentioned by our experts here already, material efficiency, energy efficiency, and fuel switching, using hydrogen and carbon capture and utilization. These technologies are across the board, if I understand the question correctly, and it's not just for one specific industrial sector, like electrification, heat pumps. It's not just for industry. It can be used for buildings too, right? So these technologies are, some of them are not totally to the end users being used due to a number of reasons, electricity cost, and they don't have it, they don't know it's available, you know, they haven't seen somebody use this, they have questions about it. So there's a number of things that are hindering the adoption of these technologies, but the concepts and the frameworks, I would say that applies to a number of the industrial sectors, even though industry sectors is so different, you know, from pulp and paper to chemical production, but the concepts are there. And one of the for this report, we stated that a relatively medium to high level, I would say, kind of covering making the broad, you know, the strokes and saying, hey, here's these areas, don't forget them, take a look at them, policymakers, they're there. But in some of our like research work, we dive into the steel industry. We recently finished the steel roadmap for China, and we dived into specific applications for steel. On the building material side, we dived into each of the building materials, and we do energy efficiency benchmarking for different things. So so we do need to have that big picture, especially for the policymakers. That's why I think the value chain perspective, it's so important, because the cement industry will be very interested in how to reduce clinker, but they may not be interested in how concrete is used at all. But for the policymakers, they do need to know that. So I think those things need to be mentioned. Sorry, that's too long probably.
No, that was great. Thank you. Thanks for that. I also was curious, sort of tying together one of the recommendations in the report and the comment that Jackie made. So, you know, in the report, one of the recommendations is around, you know, first demonstration projects. And so I'm curious if you have any particular examples you'd want to highlight, and then bringing in Jackie's point, you know, about not just having one demonstration, but, you know, replicable models and things that can be scaled up and replicated in other areas. So I'm curious if there are any examples of particular companies or facilities or approaches that you think are worth pointing out or highlighting in some way. That can be for any of the panelists.
I know that we are quite focused on a few that are specific to industrial subsectors. So, for example, inert anodes in the aluminum sector, carbon capture and storage in the cement sector, and green hydrogen, direct reduction of iron in the steel sector. And in the U.S., part of the Inflation Reduction Act money that Julia mentioned was about $6 billion at the Department of Energy that is going to support industrial demonstration projects. So we think that this is really a ripe opportunity to help stand up some of these first-of-a-kind projects that could be really transformative for these industries.
Yeah, and just to expand on that a bit further, I mean, I think Jackie made this comment as well during her remarks and during her feedback on the report, but the range of technologies that can be applied are so wide I mean, they're so wide ranging in that some of them are very much what we might think of as low hanging fruit, like industrial heat pumps, which Hong Yu had mentioned, and using those to increase, energy efficiency of industrial facilities. At the same time, though, when we're talking about even things like industrial heat pumps, the size of them is so much larger than what we're used to putting into a different type of building that it, strains the actual process and strains the investment in a different way. And so we also have to kind of wrap our heads around that, even to do something like energy efficiency, the timelines for payback might be longer than they would be in other sectors. And it might also require that the government or whoever provide a bit more of a subsidy in order to have some of those investments actually be made and on the time frame that we need them to be made in order to have emissions reduced. So in California, for example, the California Energy Commission, through a program called Indigo, is actually offering $100 million worth of funding for industrial decarbonization for things like, industrial grade heat pumps, so that facilities can undergo these sorts of changes. But that's something that we would, consider low hanging fruit. When it comes to some of these more experimental technologies, or I shouldn't say experimental technologies, but technologies that are going to be demonstration for right now, and that hopefully will move up to scale. I would say, actually, even though maybe it's traditionally known more as being a bit conservative, the cement and concrete sector in the US in particular has both bold goals and is starting to, investigate, I would say, the application of these technologies to their facilities. And that's an area in particular where, when you talk about CCS or CCUS or any combination of the C and C and U and S, I'm actually quite excited, because I think it'll be a way of basically reducing the risk for other sectors that are also going to be looking at CCUS technologies.
Okay, thank you both for those responses. We have a question for Professor Zhang, who mentioned that in China, 80% of steel manufacturing is from highly polluting blast furnaces. And so there's a question around how strong is the push to convert to more efficient electric arc furnaces? And are there governmental incentives, or are they more market-based? So Professor Zhang, I wonder if you want to come in on that question.
Okay, thank you. It's a good question. 那么我这个再用这个中文给大家回答一下。实际上是不是80%，应该说90%， 90%以上的这个都是高炉转炉流程生产的。那我们国家现在中国现在这个电炉流程只占10%。主要原因有以下几条，就是一个是目前的这个废钢scrap 就是废钢的这个资源还不足以支撑这个电炉炼钢的一个发展。另外就是我们的这个成本这个成本非常高，所以现在电炉流程的推进呢，这个政府层面是在积极的去引导。有序的引导这个电炉这个高效的这个 efficient arc furnace 这个发展，但是呢，现在这个市场呢，还是有一些问题比如说近期来看，这个电炉炼钢呢是亏本的就是这个亏损非常严重原因就是我刚才讲的，一个是废钢的价格资源问题另外就是这个电价的这个不像这个国外这个优惠的电价还没有，但是呢，从国家的层面，从行业的层面来看呢，我们现在是积极在推动电炉流程的发展，但是也不是说像大家想的要把这个高炉转炉流程停下来，然后完全去发展电炉流程，这个在中国也不太现实。我在多个场合也讲过，中国的高炉转炉流程生产的高品质钢材是在世界上是非常成熟的一个流程只不过现在面对的能源消耗高、碳排放比较大，所以这样的这个挑战，所以要做一些转型的发展。那么这个 这个路子可能很长啊。从我们的前期的研究过程当中，说到2025年，可能我们电路流程占到15%啊，再到30年啊，再到50年，可能到30%到45%这样的一个比例。但这个过程当中也是要取决于我们的废钢资源和电价，包括技术的支持啊。那么我们现在在中国的市场呢，也在研究高炉转炉流程的深度脱碳问题。比如说宝武钢铁在这个新疆81钢铁做的这个负氢循环的高炉啊，实际上就是想在这个高炉的流程上，然后把碳降下来啊，从而指导这个生产。所以未来的路径很多啊，不一定说是这个一定要全部转为电炉去生产，这跟市场呀、跟这个技术、跟需求都有很大关系啊。我不知道我这个问题是不是回答清楚？谢谢您的提问。
Great, thank you. A few of you have mentioned green hydrogen as a potential opportunity. I'm curious if anyone has perspectives on how the opportunities are similar or different in the US versus China. Are there similar opportunities, or do you think are the contexts very different? Anyone want to comment on that?
Oof, this is a really good and meaty question, and it seems like we're all going to have to answer it in our own way. And I'll be honest, I'm less familiar with the context in China, and so I'll answer more from the perspective of the US. Oof, and Jennifer, this is also a tough one too, because I think even in the discussion of just hydrogen production overall, we're starting to move away from the colors, right, and towards more what the emissions intensity is going to be of the hydrogen itself. And I think that's actually a really good direction to be moving in, because especially when you talk about electrolytic hydrogen in the near term, and maybe it was Hongyu who said this before, in the near term, you're not always talking about emissions reduction overall based on the cleanliness of the grid. You might be talking about some emissions increases. So with that said, I mean, again, I think that the hydrogen landscape in the US has very much changed because of what the Inflation Reduction Act is doing to the economics of purchasing the hydrogen and just the cost of the hydrogen, making it at cost parity in some cases to some of the fuels that are already being used. So we don't see the green premium necessarily that we're seeing with other fuel types, including at the moment still with like sustainable aviation fuel. And I think that's going to be just a driver of investment in hydrogen production in the US. I think what it's also going to be is a driver of hydrogen exports to other markets, especially other markets where there's not necessarily, the same, I would say, a combination of political interest and financial logic behind doing hydrogen production domestically. And so you might actually see, especially out of the Gulf Coast, much more in the way of hydrogen exports than might have otherwise been possible without some legislation and some tax credits to help with that. The thing that I think we don't talk about enough is just electrolyzers, the availability of electrolyzers, the price of electrolyzers. I mean, talk about a lack of a transparent market. That's a place where, there aren't that many producers of electrolyzers themselves. There's no incentive to drive down the cost of electrolyzers, at least not now. And because there are so few projects, you don't really have the economies of scale. So I think, what we're seeing in the hydrogen production space right now is a push towards looking at emissions intensity rather than just keeping with this green or nothing mentality. And also starting to tease apart, if you are going to push for green hydrogen or electrolytic hydrogen, then you really have to push on the electrolyzer market and have a pretty steep reduction in costs, not to mention a steep increase in availability.
And Jen, if I may, I'll just, Julia, that's great. Thank you. And thanks to bring up the electrolyzer. So that's great to hear your perspective on that. I would just like to add from the the Chinese perspective on the China side, and from the industry perspective, I see that hydrogen is potentially a very hot commodity that all the sectors, transportation, chemicals, ammonia, and even cement and steel are all kind of interested, wanting to get a hand on it. And for steel, for example, since we have Professor Zhang, the steel expert on here, I would like just to throw out there and see what you guys think, that I see that the steel plants, steel mills, especially their integrated mills, they're looking to have another way to produce primary steel where they are located, would play a big role. How could they have access to renewable electricity based green hydrogen? Sorry, Julia, I use the color coding. How could they use that lower carbon hydrogen? And if they're closer to some of the renewable resource areas, such as in Mongolia, such as Xinjiang, such as Southwest, where they have hydro, they will have an advantage, and that would potentially mean they'll have to, move to a different location. But I would say that's probably a long-term, mid-long-term perspective on that. But for steel industry perspective, that's where I say, how are they gonna get to have that hydrogen? So that's something to add.
And I similarly, as Julia, don't have much context on China, but in the U.S., hydrogen is really positioned to take off with extremely generous tax credits in the Inflation Reduction Act, as well as the hydrogen hubs. And so there's a ton of interest, both in the private sector, federal, state levels. But at the Natural Resources Defense Council, we're really focused on making sure that it is truly clean. And, as Hongyu said, hydrogen is often mentioned as the cure-all in many different conversations, but it's relatively inefficient to produce. So we are advocating for using it in targeted applications where there really are really difficult to decarbonize applications, and not where there are more efficient or cost-effective decarbonization options, such as buildings.
Okay, thank you so much all for those perspectives, really helpful. We're coming toward the end of our time here, so maybe just one more question. Maybe to kind of loop back to where we started, Julia started us off with, some of the financial investments under new, federal legislation here in the U.S. I'm curious if for any of our panelists, if there's anything else on the finance side that our panelists would recommend for the U.S. and China in terms of promoting new technologies or helping drive industrial behavior change. Any recommendations or suggestions you have on kind of financial incentives? Okay, maybe that was a tough one. Does anyone want to come in on that? If not, we can move on.
Yeah, I mean, it's a great question. I just, so it's interesting. We've hosted a couple of workshops, again, in the US context. So with federal policymakers, state policymakers, and local policymakers, both in Texas and California. And what was really interesting about having those conversations, actually, the three levels of government all in a row, was that, there are financial incentives available through, the federal government. There aren't really at the state and local level. I mean, there's grants, so there's money, but there's not, loans or other type, tax credits, other types of financing mechanisms at least on the public side that are available. So I would say that is one area where we're seeing gaps, especially in state policy across the U.S. is that we just don't really have, some of those financing mechanisms available. And I wouldn't say right now, although I might be corrected by somebody in the audience or on this panel, that really the private sector or private finance, private capital is coming in to sort of bridge the gap. I think we still need a bit of a push in that direction. But yeah, I mean, the reason I was silent is because I can't really actually think of, you know, what the other incentives, financial incentives might be beyond what we're seeing in the federal government.
And sorry, Jan, that's a hard question. I would just add, when we talk to the experts in China, and whether it's on steel and cement, for example, cement and CCUS always came up, and the Chinese experts would always say, well, in the US they have 45Q, and yes, so you know, from the industry, the manufacturer perspective, they really would like to see some substantial, tangible incentives, as always. And right now, for the industries in China, it seems like there's more of a, you know, still in the work, I would think, and the substantial used to in the 12th five-year plan, the 13th five-year plan, there's financial awards on energy efficiency retrofits. So that's a big improvement, that's a big incentive, and really move the needle on energy efficiency. So I would really like to see something like that to happen in the Chinese industrial sector.
Okay, thank you all for bearing with my my questions. Great. So we are unfortunately coming toward the end of our time. I just want to thank all of our panelists for their expertise and time and perspectives, and for engaging in this discussion, as well as thank our audience for joining us. This event, you know, is being recorded, and so we'll later have the video up on the website, and be able to share it with anyone that may have missed it. We really appreciate your perspectives and engaging in this conversation with us. I hope that you'll check out the report if you haven't already had a chance to. And thank you everyone for your time, and have a great evening or morning, wherever you are. Thank you.
Thank you so much.
Thank you.
Thank you.
Bye.
Thank you.